Okay, so let's go over the solutions for the test. Some of you did quite well, and some of you did not. So I'd like to go over what I perceive to be the correct solutions to help you. And I'll also bring your test papers in if anybody wants to take those home and then compare them with uh, the solutions that are being posted or discussed here. So for question number one, what you needed to do was you needed to calculate, you basically needed to calculate first the specific weight of gasoline, and how you do that. You were to multiply 0.68, which was given, by specific weight of water in imperial, which is 62.4. That gives you 42.43 pounds per cubic feet, right? So then what you need to do is you need to determine the area of the wall. So the area of the wall, you've got the height, 12 feet, and you've got the width, 40. So the area of the wall is 480 square feet. So the resultant force would be the specific weight of gasoline multiplied by half the height of the wall times the area. So that's 42.432 times 12 over 2 times 480, which should give you this answer here. And the center of pressure, it's given right in the formula. It's basically d by 3. And so, or height by 3. And the height is 12, so you divide it by 3, 4 feet. Okay, so that was the first one. Let's take a look at the next question. So in this case, the formula that would be written out would be the pressure of air is equal to pressure of the atmosphere, which is going to be 0, plus the pressure of the mercury, minus the pressure of the water, minus the pressure of the gasoline. It's going to be 0 plus, so it's 73, sorry, there you go, 73.98. How do you get that? By this calculation here. How do you get the pressure of the water? By this calculation here. And how do you get the pressure of the gasoline? By this calculation over here. So that would allow you to solve this. It'll be 0 plus 73.98 minus 26.79 minus 5.33, which is equal to 41.857 kilonewtons per square meters, and that's also kilopascals. So that was question number 2. For question number 3, you've got a storage drum with the crude oil having a specific gravity of 0.89. It's 32 feet deep and it's open at the top. So what's the pressure at the bottom? So all you need to do is calculate the pressure based on this formula. Pressure is equal to specific gravity times the specific weight of water times the height. That's going to be 0.89 times 62.4. Why? Because it's SI or imperial units times 32 feet. So that would give us 1,777.152 pounds per square feet. Divide that by 144 square inches. That would give you 12.34 pounds per square inches. Okay. In the case of question number 4, determine the pressure at the bottom is what the question says. So the pressure of the air, since it's vented to the atmosphere, is 0. So the pressure of the oil is going to be specific gravity of oil times specific weight of water times the height, plus the same formula for the water. So this becomes 0, the air. And for the oil, it's going to be 0.85. It's given here, 0.85 times 9.81. Why? Because it's in SI units this time, times 0.5. See, the depth is 0.5 plus 1 point, plus 1 times, not 1 point, plus 1 times 9.81 times 0.75. In essence, you don't really have to multiply it by anything. The specific weight of water is going to be 9.81. When you multiply that by 0.75, and you add that and you get the answer, 11.725 kilonewtons per square meter, which is also kilopascals at the bottom of the tank. And in this case, all you have to worry about is the height. You know the specific gravity is 2.6, multiply that by 9.81, and multiply that by the height. And you should get 102.024 kilonewtons per square meters, which is also equal to 102.024 kilopascals. So that was what you needed to do to get the full marks in the test. Hopefully, you gained something from this review, and that you'll be better prepared for test number 3, which is at the end of the semester. For now, what I recommend is that you focus on the tour, the assignments, and the term project to try to get good marks there.